Hi guys, so today is December 11th, 2020, and we are going to be finding the GCF of a set of numbers using prime factorization. And in order to do that, we need to discuss a couple of things. Hopefully you may remember them. We need to know what is the difference between a factor tree and prime factorization. So a factor tree is just a method used to get the prime factorization of a number. And I'm going to show you what that looks like right now. So let's say we were to take the number 30. So we're going to use the factor tree, and the factor tree tells us to split the number 30 into two numbers that 30 can be divided by. Means two factors, any two factors that I want. So to start with, the first numbers that come to mind for me are 3 and 10. Now I know that 3 is a prime factor, so I'm done breaking that down, but I can go over to the factor of 10 and break that down. And I know that I can divide 10 by 2. It's an even number, so I know I can divide that by 2, and 10 divided by 2 is 5. In other words, 2 times 5 are factors of 10. Here I also notice that 2 and 5 are also prime numbers. Those are numbers who only have two factors, 1 and the number itself. At this point, I'm done breaking this down because 3 is a prime number, 2 is a prime number, and 5 is a prime number. There's nothing further that I can break those numbers down into. Now what I'm going to do is I'm going to go ahead and rewrite these numbers, and I'm going to start with least to greatest. So I'm going to write 2 times 3 times 5. You could cross it out each time you use a number so you don't forget that you've used it. We now have the prime factorization of 30, which is 2 times 3, which is 6, times 5. That is the prime factorization of 30. The factor tree was the method used to get the prime factorization of 30. So this right here is my factor tree, and 2 times 3 times 5 is the prime factorization. Make sure that you have a notebook and a pencil so that you can get started when we start working on the examples. Today we are going to be finding the GCF using prime factorization. We're going to do that by making factor trees. So the way to make a factor tree is we're just going to start with, we have these two numbers. We want to find the greatest common factor. That is the largest number that they both have in common when being divided. So we're going to list off 12 here at the top, and you want to divide that number by prime numbers, meaning a number that can only be divided by 1 in itself. So 12 is even, and we know that 2 is a prime number, so we can divide 12 divided by 2, and that gives us 6. 6 is not a prime number. It can be divided by 2 and 3. 2 is a prime number, and 3 is a prime number. So we'll list that here like this. Once you have that and the numbers can't be divided anymore, you know you've finished this factor tree. We're going to go on to the next number, 24. So we'll list that at the top. And 24 is even, so we know 24 can be divided by 2. 24 divided by 2 gives us 12. 12 is not a prime number. It can be divided. It's even, so we'll start with our prime number 2. What can 12 be divided by? 2 and 6. And we're left with 6 here still that can further be divided. 6 can be divided by 2 and 3. So we've listed off our factor trees here. Make sure you have this copied down in your notebook. The next thing we're going to do is look at the factors that are in common to both trees. Now you can circle them. I'm going to highlight here for this example so we see that we have some numbers that are in common. The numbers that we can start with that are in common are 3 and 3. We also have 2 at the bottom and 2 at the bottom here. Now moving up, we also have 2 over here and 2 over here. We stop there. Okay, there are no other prime factors that they have in common. Yes, there are 6. They both have 6 as a factor, but we want a prime factor. So now to find the GCF, what you do is you list off these prime factors. So we're going to write GCF equals, and we're going to multiply them. 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. That means the greatest common factor, the largest number that both of these numbers can be divided by, 12 and 24, is 12. Let's try another one. So let's try the GCF of 24 and 60. We'll start with 24. It's even, so we know we can start by dividing 24 divided by 2. That gives us 12. 12 divided by 2, 6. 6 divided by 2, 3. We're done. Let's list off the factors for 60. We'll start at the top. 60 is even. Divided by 2, 30. 30 divided by 2, 15. 15 cannot be divided by 2. However, it is not prime. 15 can be divided by 3. 15 divided by 3 gives us 5. We're at the bottom. Those two numbers can only be divided by 1 in themselves, so we're finished. The next thing we do is highlight, circle the numbers, the common factors, the factors that are in common to both trees. So we have 3 and 3, we have 2 and 2, and we have another 2 and another 2. So again, we will list off our GCF is equal to 2 times 2 times 3, which gives us 12. Okay, so now you will see that in Google Classroom I have linked a game. So you'll just click on that link. It's going to take you to Math Playground. Right here we will click on the puzzle piece to enable your Flash, Adobe Flash, and click Allow. Okay, so we're going to find the prime factorization of a number. So here we have 84. This is an example of how it works. So I know that 84 is an even number, so I can easily divide that by 2. So I can start by putting a 2 over here, and that's a prime number. And then I can put 42 over here. You are allowed to use a calculator if you need to, and I'll click the check button. So now 42, a couple of things come to my mind. I could divide it by 2 again. However, I know there's a prime number that I could divide this by, and that is the goal. We want to get to the prime numbers. So I know that 42 can be divided by 7, and 7 times 6 is 42. They are the factors of 42. Correct, and now I'm down to 6, which I can do 2 times 3, and check that. And I've done it. And here you see at the bottom, the prime factorization of 84 is 2. It goes from least to greatest, 2 times 2. So right here I have 2, here I have 2, times 3 times 7. Notice the prime factors are shaded in and they're circled. So 98. Again, it ends in an even number, so I can easily divide that by 2. That is always a great clue to get you started. So I'll put 2 here, and that is 49 here. And 7 times 7 is 49. So the prime factorization of 98 is 2 times 7 times 7. Here, so you can notice I have the prime factorization looking at it for 80. So now I'm going to put an example in where I'm not putting both numbers in or not prime numbers. So here, you'll just simply factor down each side until you get to all of the prime numbers, like this. And there you have all of the bottom branches of the tree are the prime numbers. So we have 1, 2, 3, 4 2s. 2 times 2 times 2 times 2 times 5, that gives us 80. Gone through 5 practice problems. When you finish that, once you get through 5 problems, you're going to get this option to press the menu button to try the next level. So here we'll go to the menu button, and now maybe I'm going to try this, find the prime factorization of 2 numbers. Okay, so here we have 56 and 12. So I'll start with 56, and I know that that can be divided by 2, and 28. Start with that. And 28 can be divided by 7. Times 4 is 28. And then we've got 2 times 2 here. Okay, there's my prime factorization of 56. It's 2 times 2 times 2 times 7. Now I've got to get it of 12. So let's do 3 and 4 and 2, 2. Now we're going to get the GCF. So here we have the prime factorization of both of these numbers down here. We're going to get the GCF. Another way to get this GCF is to circle the factors in common. So here we go. We're going to drag the prime factors of each number to the given diagram. So the common factors here. So we have 2. Okay. 2 is a factor of both 56 and 12. So, and see what I did? I dragged that here and it shaded it in here. We have another 2. Okay, we don't have anything else here. The factors of 12, this is going to go fall in here, this will fall in here, and this will fall in here. So what is the common factor here? 2 times 2, which is 4.